This video is going to serve as a recap of what we have learned so far in Chapter 6, which were the three methods to solve a system of equations: graphing, substitution, and elimination. While there are no actual notes with today's lesson, you should make sure that you're paying attention to this video because it's serving as a review to help you better understand these three methods. So first, just a reminder that a system of equations at this point is when we have two equations in the same problem. And we have two variables that are usually x and y. We learned these three methods, and that's what we're going to talk about in a few moments. But first, we're going to take a moment to look at the three types of solutions we could have in a system of equations. First one we're going to talk about is having infinite solutions or infinitely many solutions. That's when the two equations in your system of equations are actually the same line. They have the same slope, they have the same y-intercept. If you were to graph them, they would literally be the same thing. One would graph right on top of the other one. So in that case, since our solution would be wherever the lines intersect, every single point on that line is an intersection. So every point on that line is a solution to the system. That's why we have infinitely many solutions for that type of problem. Another possibility is for us to have no solution whatsoever. That occurs when our two lines are parallel, meaning they have the same slope but different y-intercepts. Like here, if we have slopes of 2 and y-intercepts of 5 and 1, we see that these lines are never going to cross because they have the same slope, really because they're parallel. So since the solution of a system of equations is the point where the lines cross, since these lines never cross, there is no solution to this system. These are the two special cases, but most of the time we actually wind up with a system of equations that just crosses in one point or really has one solution. So our last option or our last case is when we have two lines crossing in one point, so our system has one solution. This is just a random example here. They have different slopes. We see that the lines cross in one point. Please make sure when you're answering a system like that you write the answer as a point. So you find the x value, the y value, write it with parentheses and a comma between. The next thing we're going to talk about is the three methods that you have learned to solve systems of equations. In section 6.1, you learned the graphing method. In order to solve a system of equations by graphing, you need both equations in your system to be in a form that you can graph from. So ideally, y equals mx plus b or slope-intercept form. Then you'll graph both lines. Remember, for your slope or your m, you want to use rise over run to find other points on your graph. Once you have graphed both lines, you're going to find where they cross, or in other words, you're going to find the intersection point. And you'll write that as a point, and that will be your answer. We did graphing in section 6.1, and then in section 6.2, we learned substitution. In order to solve a system by substitution, you need to get either x or y alone. So you want one of your equations to be in x equals form or y equals form. Then you'll plug what you have there or substitute it into the other equation. Substitution is the best method to use when you have x or y by itself already. Sometimes directions will tell you you have to use substitution, but some problems will just say to solve the system of equations, and it won't tell you what method to use, so you can choose if you want to use any of these three. Usually you would choose substitution or elimination. But again, substitution would be best to choose when you have x or y by itself. The third and final way to solve a system of equations is elimination. That is the method that we learned last class in section 6.3. In order to solve a system by elimination, we need both equations in standard form, or ax plus by equals c, and we need opposites so that the x's or the y's can cancel out. So sometimes we have to multiply one of the equations by a number, or sometimes even both of the equations by numbers in order to get opposites. The point of having opposites is so that when we add down, we're eliminating a variable, hence the term elimination. Now, elimination is the best method when you're given standard form already. So if both equations are written in standard form, that's usually a hint that elimination is probably your best bet. So that's just a little recap of the three methods that you have learned to solve a system of equations.